So we continue our statistics. Now we move away from cumulative frequencies. We go to histograms and frequency density. So a histogram, it looks something like this. So you can see different bars of different heights and different widths. So we can say histogram is just a bar chart where the bars can be of different widths. You can see this one is longer on the sides, this one is really thin but longer. So this changes them from nice, easy to understand diagrams into simply incomplete. Okay, so histograms show frequency density. Okay, so the axis on the histogram is called the frequency density. So this axis here gives us the frequency density. Okay, and here is where you have your classes. So remember, frequency is just another way of saying how much or how many. So you rearrange to work out how much. So the frequency is given by the formula frequency density times the class width, okay, which is the same as area. So when you want to find the frequency, okay, when you want to find the frequency for a histogram, it is just the area of this. Okay, frequency is equal to area of bar. Okay, it's equal to the area of the bar. Okay, and we know the area formula for most of these shapes. They are rectangles, okay, so area will just be length times the breadth. Okay, so your length here is actually the frequency density. Okay, how long it is actually. So the length here will be the frequency density. I'll say FD, and your breadth here is simply the width of the class, so we'll say W. So this is what they've written here, FD times W, which is class width is equal to area of the bar. So that said, let's look at an example. Okay, so here's an example. So you have, this one says the table. Okay, the table, let me do this. Let me start off with that. Okay, so the table and the histogram show the length of beetles found in a garden. So this was the histogram, and then here use the histogram to find the missing entry here. So we are trying to find the missing entry here, meaning we are trying to find what is the frequency here. So from 0 to 10, there's a frequency of 32. 10 to 15, which is this bar we are looking at, there's a frequency of 36, and then 15 to 18, here is where we have nothing at all. Okay, so we are trying to find the frequency for this bar here. I'll call it bar X. We're trying to find the frequency for this. The rest we have the frequencies. So this is simple. It's just to find the area of this thing. Okay, so what you're going to do, this says from 15 to 18. Okay, from 15 to 18, and then the frequency density here. So what we can do is just to find the frequency densities. So we can say the frequency density. So the frequency density now will simply be, we had given the formula. Okay, let's look at, we had given that formula for the frequency density, frequency divided by class width. Okay, that is the formula. So the frequency density is just frequency divided by the class width. So for this first case, you find that let's do an example using the first column here. So on the first column, you have a frequency of 32. the class width is from 0 to 10, so you just say 10, and this will give you what? 3.2. so this was the frequency density for the first one. Okay, now for this particular set here, for this particular set here, we need the frequency. Okay, we only need the frequencies, we are lacking the frequency. Okay, so we're going to say what is actually the width here, 15 to 18. How much does that give us? 15, 16, 17, 18. So this gives us 3. Okay, this means that from here to here it's just 3, so you just subtract 18 minus 5, and that gives us a what? A 3. Okay, that will give us a 3. Okay, and then so the third bar to find the frequency for the class, so frequency density is equal to 8, and class is that. So the frequency density times class, this is what you get for this particular set. So let's just do this for this one. Okay, so the first thing here that we are trying to do is to find the frequency densities. So the frequency densities will give us how long this thing is. So the same formula that we used, we said frequency density is just the length. Okay, so frequency density is just what? Length, and it's given by frequency over the width. So frequency over the width. So this will be frequency for this one. We said you look at the width is 0 to 10, so we said frequency is 32, 0 to 10 is 10. Okay, okay, so this gives us 3.2. Now we can go on to find this one, so we are going to do 15 to 10 to 15 is 5. That's 6 divided by 5, you get 72. So you find that the length from here, it is actually 3.2. For the next one here, it is 7.2. So the length for this one now, if this is 7.2, when you add all the smaller boxes, so that will be 7.2, 0.3, 0.4, 0.5, 0.6, 0.7. So you find that the last figure here will basically be 8. Okay, basically be 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. So looking at the scale that they are using here, is for this to be 3.2, so this means that they are actually dealing with so this will give us an 8 here, the last mark. So looking at what they did, so this is 2. Okay, that's the scale they were using. This is 2, 4, 6, 8, and this makes sense actually. Okay, so meaning the last figure here will be 8. So this means for this particular set, your frequency density is 8. Okay, now you can find the frequency. Now you say that frequency is equal to frequency density multiplied by the width. So the width here, you get it from here, 18 minus 5, that is a 3. The frequency density is just the height for this thing, which is 8, and this will give to us 24. So this means that the frequency here is actually 24. So that is about this histogram. Okay, that's what you need to know. Then use the bar to find, use the table to add the bar for the class that to histogram. Okay, so for the other class, which is which one now? This one here. Okay, so how do we add it on the diagram? Okay, so here's what we are going to do. So for this particular set, all we need to do is to find because we know it's from 22 to 30, so it occupies the last mark there. So all we need to do is to find the height. How long is it? So how long is it? That is the frequency density, and the frequency density is for this particular set, the frequency is 16 out of how much is it? 22 to 30, that is 8. So this gives us 2, and remember 2 is actually here, so meaning it's just this long. So you can just do this. Okay, so that is how long it is for the last one. And here you're good to go. Okay, you're good to go. Just color this nicely. Okay, and that is all. Okay, all right. Alright, so let's see, we can go to the next thing. Estimate the number of beetles between 7.5 and 12.5 millimeter in length. So using the formula frequency density times class, you find that you do says 7.5 to 12. So 10 minus 7.5. Then you work it out like that. You find that you get multiply the frequency density of the class by the width of the part of the class that you're interested in. Okay, so the part of the class that you're interested in, starting from this. Okay, so this is the frequency density, then what you're interested in, 7.5 to 12. Okay, so 10 minus 7.5 and 12 minus 10, this is what you get, and you just multiply everything that you would have estimated the number actually. Okay, so let's go to something else. So under scatter graphs, so a scatter graph, just as the name would suggest, it's something like this. Okay, so this is how scatter graphs looks like, and the first thing you need to understand about scatter graphs is what we call correlation. So you can see, as when you're getting these values here, they more like following in a certain line, so we call this a strong positive correlation. But then looking at this, find that you have something, you have a number here, a number there, a number there, so this is very weak correlation, though they seem to like follow a pattern, but then it's very weak. Okay, compared to this one here, there's actually no correlation at all. Okay, so now whenever you have something like this, we usually do this to come up with what we call the best line, the best fit. Okay, so the best fit now would be where you connect the lines, especially those that are actually in the same line. Okay, so you can say, okay, which one here look like they are in the same line, and you try to draw a smooth line. Okay, just to correlate them properly. Okay, so a smooth line will be drawn like that. So you call this You make such a line, you call it the best fit. Okay, here we can't come up with a best fit because the correlation is very weak. Or maybe you can try to do this and call this your best fit, but the correlation is weak. Here there's actually no correlation. Okay, there's actually no correlation. So a strong correlation is when your points make a fairly straight line. For this one, okay, they make a fairly straight line. A weak correlation is when your points don't line up. Okay, so let's look at let's go a bit further down. We see what they mean, the best fit. So for the best fit is how you actually do it. So when you look at this part, you find that the points were aligning like that, right? So you just try to make a best fit line like this. Okay, so the best fit will help you. So they draw a line best fit to estimate the number of visitors when the temperature is 15 degrees. So this is the best fit, right? And then you're given a temperature of 15, so you just go on temperature of 15 degrees, you go like this, and then you get the number of the people from this diagram. Okay, so the best fit will just help you. Okay, to help you to do your calculations properly. Okay, so that is what you need to know under these scatter graphs. Okay, coming up with your best fit. Okay, so you find that you have other marks that can come way off. So you find that there is some correlation, but then you get other values that are just way off. They are very far from the remaining values. So these such values, we call them outliers. Okay, you could have maybe made a mistake when entering. They are called outliers. Okay, so in case you have most values ranging in this space, but then you get values maybe as far as this side, you will know this is an outlier. Okay, you know that is an outlier. Okay, so we can just move further now. Okay, so you have as well line graphs. Okay, you have line graphs. Let's do the line graphs. Look at line graphs and other graphs. Okay, so line graphs can show time series. So line graphs are shown like this. Okay, just draw a line connecting. It's not even a straight line. Just follow the points on your. So with time series, a basic pattern often repeats. Okay, so I think we've seen a number of these type of graphs. Okay, but on this one, you can also, the overall trend can be shown by a trend line. So you can just show a trend line showing that there's a bit of an increase. Okay, whether the values are generally getting big or generally getting smaller, you can just show it, and so you can find that they are increasing a bit going this side. So you draw your trend graph like that. Okay, so this is not that difficult, but what is important under this is the frequency polygon. Okay, so under the frequency polygon, looks similar to a line graph and is used to show the information from a grouped frequency. The frequency of each class is plotted against the mid value, and the points are joined with a straight line. So here, if you have let's say you have a point here. Let's say you have a point. Your point was just here. Another point was there. Another point was there. Another point was there. So you just join them like this. Okay. So this was what was plotted here. So the mid value, remember the mid value, how do you find the mid value? This plus this divided by 2. So 20 plus 30 divided by 2, that gives us 25, which is the value which comes here. So meaning here they plotted what now? So 25, 12, right? So 25, 12, this is the point that they had here. 30 plus 40 divided by 2, you get 35, which is the value that is here. So 35, 21, which is the point which is here. So on and on. So what I was explaining, then you just mix them like that and get this. Okay, so one important thing that usually comes on the exam is the pie chart. So the pie chart, so what you need to understand about the pie chart is that it adds up to 360. Okay, a pie chart adds up to 360 because you are dealing with degrees. Okay, and round circle in degrees is 360. So you have 70, 100. Here you don't know, red you've got, but this one, whenever you see something like, just know it's 90 degrees. So if you see something like this, just know it's 90 degrees, like what you can see this here. So this is 90 degrees. Okay, so to find this one, the missing one, you just add everything. 100 plus 90, that is 190, plus 70. Okay, 190 plus 70. So you say 190 plus 70, you get 9, 10, 11, 12, 13, 14, 15, 16. 6 carry 1, so you get 260. You see that? So to find the missing one here, you're just going to say 360 minus 260, you get 100. So this means this part here was 100 degrees. Okay, it was just 100 degrees. Okay, so that's how you do it. So let's look at this example. So the pie chart shows the colors of cars in a car park. What fraction of the cars were not black, blue or red? Were not black, blue or red. So the fraction here, how do you do it? So what did we calculate here? We said here we found 100. So you say, since you're finding a fraction, so you're going to do 100 over the total for everything is 360. You can reduce this to the lowest terms. Okay, finding numbers can go there, and when you reduce it to the lowest terms, you get 5 over 18. There were 48 more blue cars than black cars, so blue cars were 48. Okay, more than black. How many red cars were there? So what you are going to do here, you say that you found in so you are told that there were 48 more blue cars than black. So you find the difference between blue and black cars. Okay, so in degrees, you do this. This is in degrees, and this will give you 30. So 30 degrees here is the difference in degrees. Okay, and that's the difference. So this difference in degrees represents the difference. So the difference in cars is given as 48, but the difference in degrees we found it's 30. So this 30 degrees represents actually 48 cars. Okay, 48 cars. Then it says how many red cars were there. How many red cars were there? So you're going to do this. You're going to say, all right, since for red you've got 90 for red, you don't know how many cars are there for red, but all you can see is that 30 degrees will give us 48 cars. So you cross multiply this, then when you cross multiply, it's going to be 30 times x, that will be 30x, will be equal to 90 by 48. You can divide by 30, divide by 30. So x now will be 0, 1, 3, 1. Okay, so that will be 3. 3 times 48, you get 144 cars. Okay, 144 cars. So that is how you work out certain things under the pie chart. Very simple. The stem and leaf diagrams help you to see your spread. Okay, so the stem and leaf diagram shows the ages of people in a choir. So 0, 1, 2, so the ages, and these are the frequencies. So the key is that 1 is equal to, so 2 is equal to 12 years old. That is the key. So what is the range of the ages? 30 minus 7. Okay, 30. What is the range of the edges? So the range of the edges, you are told that 2 is equal to 12 years. Okay, so the data in a stem and leaf diagram should be in order. Okay, and then here you use the key that you are given. So key number 1, you're told that 2 is equal to 12 years old. Okay, this means that where you have to just know that is what, 12 years old. Okay, that is 12 years old. So the range is just the distance between the highest and the least value. Okay, that's the highest and the least value. So there are 19 values, so the median is those formulas that we were using last time. Okay, so without wasting much time here, let's do this.